Now, I think this is the perfect time to kind of check our understanding of all the work that we've done and maybe also look at some of these pre-processing, data munging subtleties that we might have missed. I'll add a quick section heading here just for that. Now, the way I'd like to tackle this is actually kind of with a challenge. You see, we started with about 5,796 emails. We split these emails into 4,057 emails for training and about 1,739 emails for testing. But how many of these individual emails were actually included in the text files that we saved to our disk? Let's just look at the testing emails for now. Can you figure out how many individual testing emails were included in the txt file that we saved to the disk using the train_grouped data frame? And then compare that to the amount of emails in x_test. After splitting and shuffling our data, how many individual emails were actually included in the x_test data frame? Is the number the same? And if not, which emails were excluded and why? I recommend comparing the doc ID values to find out. Did you have a go at this? This might have been a little bit of a tricky challenge, actually. So let me show you the solution. The way I'm going to tackle this is using Python sets once again. Now, there's other ways for sure, but I think this code is terse and it's also clear. I'll create two variables which will hold on to these sets. The first one will be train_doc_IDs, and that's going to be our set of all the document IDs which were under train_grouped. Then I'll create a second set called test_doc_IDs and set that equal to a set that I create from test_grouped.docID. This will give me a comparison. The reason I'm doing this is because I can easily print out the number of individual emails using these sets. len parentheses train doc IDs will give me the number of individual emails in our training set. So that's 4,014 compared to the 4,057. len test doc IDs will give me the number of individual emails that we actually saved under the testing txt file. So that's 1,723. And we can compare this number to the length of x_test, which was 1,739 emails. So 16 emails have gone missing or have been excluded. But which ones? Which emails were excluded? Well, remember how we said that Python sets are very, very useful for checking membership? To find out which emails are included in one set but not in the other set, we can use, well, Python sets again. Only this time, we will take the difference between two sets. Check it out. If you recall, x_test.index actually stored our document IDs. If I take this whole thing and grab the values, then I can transform my index values into a Python set. To see which values are included in this one, but missing from this one, all I have to do is take the difference between the two. And that will give me the answer. Here are the 16 emails that are not included in our txt file. But that still doesn't answer the question why. We've only identified the specific document IDs that were problematic. Let's dig in and take a closer look at these messages. The first one I'm going to pull up through data.message is message number 14. So data.message square brackets 14 will show us the message text of the first email that didn't make it. And this email looks like this. It looks like a private key or a public key of some sort. It's complete gibberish. What about some of the other ones? Let's check 325, 416, and 445. 325 looks like this. 416 looks like this, and 445 looks like this. Now, I'm starting to spot a pattern here. All of these emails seem to look like a complete mess. But maybe the reason they look like this is because we had a problem reading this file, right? Maybe this is related to our encoding that we used, and this is why we're getting some sort of like Mojibake or something, right? Maybe that's the source of the problem. So let me actually pull up one of these files in my text editor. I'm going to go with file number, say, 14. The way I can find out which file this actually was is by going to data.loc and then feeding in the number 14. This will give me the actual file name. So that starts with 00095 and then something. I've located this file under my spam1 folder in my Spam Assassin corpus. Opening this file in my Atom text editor gives me the following. I got my email header up top, and then down here I've got my email body. So what we saw in Jupyter Notebook is actually the email body, right? 1-to-1. We didn't screw something up on the encoding. Now, would you like to venture a guess as to what we get when we stick this email through our message cleaning function? So clean message note HTML parentheses data dot at square brackets 14 comma single quote message. Would you like to venture a guess of what we get when we stick our message body from this particular email through our cleaning function? We get a string like this. Now, this particular string, as you can probably guess, is not part of our vocabulary. It's not part of the top 2,500 words that we're using for our classifier. And hence, this email would not have been included when we created our sparse matrix. This condition here, if word in word set, filters out if any of the words in the email are not part of our vocabulary. Now, the story is quite similar with some of these other emails, but one exception is this one that I found here, 1096. This document, data.message square brackets 1096, looks like so. And looking at this text, we see that it's not all gibberish, right? This is mostly HTML actually, right? We can see a whole bunch of HTML tags in the body of this email. And what happens when we clean this message and remove the HTML, so clean underscore message underscore no underscore HTML, parentheses data dot at square brackets 1096 comma single quote message, is that we get an empty list. This particular message contains so much HTML that Beautiful Soup, the tool that we use to remove all the HTML tags and strip those from our email bodies, actually leaves nothing behind. There's no single word that actually makes it into our list. The reason that I know it's Beautiful Soup and not our words demo or something else is if I call our other function, clean underscore message, where the HTML tags are left in, and I feed in the very same code, data dot at square brackets 1096 comma message, typo, then I get the following. I get all my HTML tags as individual words on this list. So I think that was actually quite subtle. That was something that was happening in the background that we might not have noticed while we were writing our code. But it's always good to check if your code is doing what you expect it to do. And I think this also gave us a chance to have another go at practicing using Python sets and really seeing their use in checking membership, especially if you're looking for differences and trying to see which values are included in one but not on the other one. And that's it. This wraps up our pre-processing. We've actually done an incredible amount of work in the past couple of lessons. We've extensively cleaned our data, explored our data, visualized our data, and the text files and the JSONs and all these files that we've saved to our disk create checkpoints that mean that we don't have to rerun all the work and all the code in our Jupyter notebooks. In fact, we've worked really hard to create the files that contain the data that we will feed into our naive Bayes classifier algorithm. And if you take another look at this training data and this testing data that we've created, you'll notice that all the strings, all the text has disappeared from them. We're exclusively working with numbers now. All the stemmed words are replaced just by word IDs, by integers. It's much more abstract, right? But what we've effectively done is we've transformed our words into tokens. But not only that, we've also counted how often each token appears in every email message. With this in hand, it's time to train our naive Bayes classifier. We can move on to the next step in our project. Now our Jupyter notebook here is getting very, very long, and as such, it's getting also a little bit unwieldy. So I'm quickly going to go up here and rename this notebook. I'm going to call it 06 Bayes classifier pre-processing. Click rename. And then for the next part, where we're training our algorithm, we're going to be doing it in a new, fresh notebook. That way we've separated out all the pre-processing that we're doing in one Jupyter notebook, and we're going to separate the training that we're going to do for this project into a separate notebook. And on that note, I'll see you in the next lessons. Take care.